We will move to the next paper, Integrating Digital Twins in Construction Education Through Hands-on Experimental Learning. Authors are Stephen Kangisser, Javier Irizarry, Kelly Watt, Richard Borger, and Amadeus Borger. The presenter is ready.
Yes, one moment. Okay, do you have my screen?
Yes, we can see your screen.
Okay, great. So the presentation that I'll be making here today examines the benefits that digital twin learning can offer in construction and facilities management education. We examine the value offered by teaching graduate students digital twin technology as a hands-on learning activity, the methodology of teaching digital twins as a unit, and look at student feedback and lessons learned within the context of the course objectives. The instruction discussed took place within a graduate level course at Georgia Institute of Technology. The course is intended to explore Construction 4.0 framework and the various present and future technologies that contribute to this framework and can be applied in all stages of a facility's life cycle. The course introduces students to technologies they will use in various classes within the building construction curriculum at Georgia Tech and later in industry. During the course, students work on hands-on tasks that provide the opportunity to develop practical skills with many of the technologies covered in the course. Digital twins are a digital replica of an actual physical asset. They integrate artificial intelligence, machine learning, and data analytics to produce simulation models that can be easily updated from multiple sources. In this manner, a digital twin represents the current condition of an asset. Digital twins are comprised of a physical artifact, a digital counterpart, and that which connects the first two. The digital twin of a building can be used to improve its operation and maintenance efficiency by permitting facility managers to perform what-if analysis. This can be useful to enhance energy efficiency and improve users' comfort. They can also be employed for such uses as life cycle and security planning. Such systems can enable facility operations and maintenance to improve operational efficiency from remote management and pre-planning, asset maintenance, and repair. So today, I will describe the use of instruction of digital twin technology to enable students to better understand Construction 4.0 and the technologies which enable it. The instruction we are discussing incorporated 3 parts. The first part included a series of 3 lectures delivered by guest speakers possessing extensive expertise in the digital twin domain. The purpose of the lecture series was to help students consider security, design, and safety implications throughout the building process. Key case examples from brownfield construction to existing facility improvement projects were presented, comparing existing 2D computer-aided design and building information modeling files to 360-degree panoramas through various project stages, provided it an effective means to communicate project information and to identify issues, clashes, and change orders early. Case examples were used to illustrate the benefits of virtual collaboration, pre-planning, and involving subject matter experts early in projects, and demonstrated where companies are increasing productivity, reducing rework, and improving their bottom line. The lectures presented how digital twins are used post-commissioning for operational processes, maintaining assets and facilities. Projects were shown that exemplified the creation of complex digital twins for nuclear energy and petrochemical plant maintenance. Students gained a clear understanding of the precision required for large equipment installs where LiDAR was instrumental. The final lecture in the series took place in small student teams conducted on site at the Bobby Dodd Stadium. Bobby Dodd is the football stadium located on the Georgia Institute of Technology campus. This session was given while seated in the stadium stands, staged to give students a feeling of being on a project site. The starting point for this lecture was a team discussion around the site capture approach, techniques, capture method, and deployment methods. Discussions included site preparation, staging, lighting, outdoor conditions like weather, prioritizing critical areas, and discussing what type of documentation is required for the scope of work, expected deliverables, and outcomes. Following the lecture series, students from the class worked in pairs and were assigned particular areas in the Bobby Dodd Stadium to capture. Each team applied what they learned on 360-degree imaging and judged how many panoramas to take and where to capture them. They employed 360-degree cameras in conjunction with a field capture phone app to collect data. The camera was either mounted on a hard hat or on a mobile robotic device. Each team was instructed on exact procedures to follow in data collection and monitored by the instructor. After completing the assigned capture area, each team reviewed their work and uploaded it for cloud processing. Students learned how to identify assets, current nomenclature, tagging, and classification. Each student was next expected to tag 10 assets, add attribute information, and upload a photo of the asset nameplate with identification information. Having gained an understanding of digital twins and essential field tools in creating these twins, students next had an opportunity to select from several of the other technologies introduced in the course throughout the semester to create a digital twin. 3 teams selected 360-degree imaging, 1 team selected laser scanning, and 1 larger team selected drone photogrammetry as their technology tool. The plan was to apply any one of these technology tools in a real-world setting. Students were requested to match the technology tool of their preference to a location in the stadium that was appropriate for the selected technology based on their client's needs. In this case, the Georgia Institute of Technology Facilities Management Department and the campus police department. These departments are actual beneficiaries of this project, and restricting the number of stakeholders that the students needed to consider helped facilitate this as a short project. The term project was divided into 5 parts. First, the students selected team membership based on technology interest and available time. Teams then met with key stakeholders of the football stadium, with each student team obtaining guidance from these stakeholders in developing a brief project scope that matched their technology tool to an appropriate physical setting, which is of interest to the client. Data collection was conducted in 1 to 2 team visits to Bobby Dodd Stadium, each visit being from 2 to 4 hours. Data compilation and evaluation was conducted appropriately for the technology tool employed, and teams presented their findings during the final class meeting of the semester. The stakeholders attended this presentation in the role of client beneficiary. The final team report was prepared and presented to the instructor at this time. These reports were combined with additional data collected on the stadium and presented to the university. Student feedback was solicited upon completion of the assignment to assess the effectiveness of meeting stated course learning objectives. Consistent themes found in student feedback concern the impact of digital twins on security and pre-incident planning for buildings, facilities, and operations, highlighting further opportunities for in-depth learning and application of effective building and construction pre-planning, documentation, and visualization to safety, security, and risk assessment. The learning outcomes inspired critical thinking on applying digital twin technology as a valuable methodology across various applications within their professional fields. So, although more specific findings are listed in the slide, we found generally that the use of digital twins provided a framework for understanding a range of technologies used in building construction. This framework proved valuable in a broad scope of learning objectives related to new technologies and relevant facility life cycle applications. The benefits demonstrated by this instructional experience can be applied in the curriculum of building construction and facilities management programs at the university and even at community college level. It is expected that the incorporation of digital twin instruction into an institution's curriculum can be highly beneficial for both graduate and undergraduate students. Students with knowledge of digital twin theory and methodology will have an enhanced ability to perform in the age of construction 4.0. Such graduates will likely be in high demand as the construction industry further adapts to the digital environment. And if there's any questions.
Thank you very much for your very nice presentation, Stephen Kangisser or Kangisser. Questions in the audience? We don't have much time, but let's give some time for questions.
Hey, Kepa, it's me again. Thank you very much. Thank you so much for sharing your experience. I'm trying to develop a course as well. Construction 4.0, more or less the same. It's really hard to develop a course like this because it seems to me that civil engineering students, there's so much that we need to teach them in order to get to do construction 4.0. Did you find it challenging, like in that sense? And the second quick question is, how many students were on the course?
Excuse me, what was the second part of your question?
How many students were on the course?
Okay. Yeah. So first of all, yes, time is critical. The entire lecture series and first round of data collection was all in one intense week of participation. And then the students had several more weeks to apply the technology that they desired. So it was a rather rapid experience and involved a lot of coordination with the university. The university had a motivation to do so because they obtained a digital twin model of the football stadium in exchange. And then as far as the number of students, that was very challenging because there are 24 students in the class. And now we've purchased more, but at the time we had only a couple 360 cameras, 2 laser scanners, and 1 drone. So the access to the hardware that was required was pretty challenging and required a lot of coordination.
Thank you so much for your presentation. I really appreciate it. We are doing the same thing or something equivalent in France, in Central Lille, but we have some help from company, from Dassault system company for that. And it needs a lot of time, in fact, for the student to absorb, to understand some technologies. So we are doing that. So only to share with you this the experience. I think that we have something that we have to do for training for our students. My question, it is an open question. Did you be confronted to some discussion with the student about metaverse?
About methodology, is that what you asked?
Not methodology, metaverse.
Oh. Yes, no, we did not get into that in this aspect. That would be very interesting, but it would be another additional step forward in this process.
Thank you again for your sharing. Thank you.
Thank you for the questions. Is there any other question in the audience? If not, we will move forward to the next and latest presenter,